Matrix, an AI-powered learning platform for technical interview problems. Now, say you look at a LeetCode problem and your first hurdle is the wording. All you have to do is highlight what's confusing to you, and you can get an explanation from Neo, your personal interviewer. Now, he's not just any generic LLM that you find on the web. He's a fine-tuned agent that's aware of everything that you see on your screen. Let's give him another example. And you can see that based on the framing, he's well aware of the problem. Now, say this gives you enough information to come up with a plan. A common pain point in solving these problems is knowing when you've spent too much time and you need to cheat and look at the solution. But a better idea is always being steered in the right direction, as with a real interview. With confirmation that we are on the right track, we can develop our code a little bit further. Let's say we're ready to test. Looks like there's an error. We've upgraded to LLM-powered error handling, so the LLM can quickly identify and pinpoint where your issue is and give you a suggested fix. And you can apply the fix by pressing checkmark, and then when we submit, we should see that our code is now running, though some of the test cases are failing. Let's say we don't know what the reason is, so we're going to take a hint. Now, as with a real interviewer, Neo is going to give you something to think about, not just a blanket answer. This one here is forcing us to consider when we're incrementing components. In practice, what this means is that this needs to be tabbed in. Let's take another hint. We see that this hint here is suggesting using a different data structure. And in practice, what this means is that we need to use a set, which is customary in graph-related problems. But if we don't know what that is, we can just look at our toolkit and then expand to find the code. If we still have questions, we can just ask about it, and Neo's going to elaborate further, and then we're going to have these two new tabs where we can animate it and interact with it. And we see that this animation pulls from this set of numbers here, and it's going to attempt to add these numbers to a set. And with a set, you can't add duplicate numbers, so any duplicates are going to be marked red and not added. We can interact with this animation by changing up the numbers. So for example, we can change to 1, 9, 1, and then hit test, and we see that we get a new animation with the exact numbers that we put in. Let's take this code and paste it into our editor. Now let's figure out how we can refactor our code to use a set. And Neo's just going to go ahead and explain it to us, but we're just going to paste in the solution for the sake of time. Now we're going to hit test to finalize our submission, and we see that all our test cases pass, and the LLM is going to grade us. It looks like I got docked for using I and node to refer to vertex. But I'm not just going to throw you in headfirst into the problem. That hasn't worked for me, so it definitely won't work for you. I'm going to build your intuition through a strictly visual approach. Each unit is going to have a high-quality explanation and an exercise so that you will learn by coding. Zoom in on this one. It's asking us to create an adjacency list from a list of edges. So let's turn this in. All the tests pass. I've handpicked these exercises for them to be extremely reusable code snippets that you'll take with you to your next problem. As you can see, this code snippet is used in solving this problem, and this problem.